Welcome everybody. I am Lisa Campbell. I'm on faculty in the Nicholas School based at the Marine Lab in Beaufort, and it is my honor and pleasure to host this informal recognition event today. This event is something we started doing a couple of years ago when we felt like we needed a little bit more time to indulge in thinking and reflecting on the accomplishments of our outgoing class of PhD students. The PhD is a pretty significant undertaking, often taking 4, 5, 6, sometimes 7 years. And over that time, a lot of things happen. A lot of academic things happen, a lot of life happens. And we really wanted the opportunity to think about these outgoing students as both scholars and as individuals. So we really thank you for coming. We thank family and friends for listening. It's a little bit indulgent, but we love to do this. If you are here to listen to what an advisor has to say about a particular student, about your student, that's great. I would encourage you to hang out for the entire event. As every year I'm kind of amazed at this about the diversity of what students in our school get up to, and it gives us a real sense of who we are as an institution. So please stay throughout if you can. I want to, before I forget, let's just say we all know that this version of this event is not what any of us imagined 3 months ago, but we are going to try really hard, me with lots of energy and smiles, to make it seem like we're doing this in person. And I want to, so we don't forget, to start by thanking the heroic efforts of Daniel Wiggins, Alexis Sharp, and Rachel O'Piccolo to pull this together. They've really compensated for us not being able to be together in person by really enhancing, I think, some of the aspects of the event. So thanks to them right from the start. I'm going to turn it over to Dean Steelman now to give her own welcome and introduction, and then we'll come back to me to tell you how the process is going to work as we go along.
Thank you very much, Lisa, for getting us started. It's always an exciting time of the year. It's one of my favorite times of the year. I regret that we cannot be together in person, given the circumstances. And I also want to say welcome to our graduates, to fellow students, friends, family, faculty, staff, everyone who can be together with us today at this acknowledgement ceremony. It's one of my favorite times of the year, as I said. And I am personally very excited to be with you today in this setting, as imperfect as it is, to celebrate this truly momentous accomplishment with you all. I am going to keep my remarks short today, and I have two duties. One is I want to just make a few remarks to celebrate your accomplishments. And the second is another sort of fun thing that I get to do is to announce the best graduate student manuscript award winners. So these are the Dean's Award that I give out every year. And so I'm going to start off with our award winners. The first one goes to Matt Ruiz, who is a fifth-year PhD student in Heather Stapleton's lab. His dissertation focuses on how prenatal exposure to flame-retardant chemicals can disrupt the thyroid hormone systems in a fetus. And he's currently investigating how these chemicals basically accumulate faster in the fetal portion of the placenta than in the maternal portion of the placenta, and if the sex of the fetus influences that degree of accumulation. Anyway, when I read this paper, I learned a lot. It's one of the best parts of what I get to do as I through this competition. His winning paper, it's an area that I didn't know very much about, so it was really educational for me, is PBDEs, concentrate in the fetal portion of the placenta, implications for thyroid hormone dysregulation. And he published that last November in the journal Endocrinology. So congratulations to you, Matt. The second student is Zhen Wang, a second-year doctoral student in Avner Vengosh's lab. For his doctoral dissertation, he's working on ways to use lead isotopes to detect the presence of coal ash contamination in the environment. And by using this sort of unique isotopic fingerprint from the ash that's derived from the coal basin where where the coal comes from and the combustion that it takes place in, he can trace the contamination all the way back to its source. So he's sort of a forensic expert of coal ash. His winning paper was lead isotopes as a new tracer for detecting coal fly ash in the environment. And that was also published last fall in the journal Environmental Science and Technology Letters. So congratulations to you, Jen. And then finally, our third award winner is Hillary Smith. Hillary is a fifth-year doctoral student in Javier Basurto's Coast and Commons Co-Laboratory. She publishes, her interests are in gender and politics in the commons, and focuses on how resilience in small-scale fisheries elevate, in how reliance in small-scale fisheries and the technologies that are used to capture fish elevate a false narrative about whose labor is really important within fisheries and contributes thereby to the relative invisibility of how women play a role in fisheries. And so another really fascinating paper, all three of them were incredible. Her paper was titled Defining Small-Scale Fisheries and Examining the Role of Science in Shaping Perceptions of Who and What Counts, which was published last spring in the journal Frontiers in Marine Science. So congratulations to Hillary as well, all three of our award winners, congratulations all. And so today, sort of transitioning to what we are doing immediately, we hear from our graduates and their supervisors across the fields, breadth of disciplines in which we excel in the Nicholas School. And so as part of my job as dean, I feel like this is a ceremony to formally welcome you to the scientific community, and it's a real milestone in your career. And it's exciting for me because I think it's never been more apparent than right now that now is a time that we need science more than ever. The importance of science and evidence-informed decisions, the lack of its use, the lack of it, has never been in sharper relief for us as a nation in terms of the role that science can play or what happens in its absence. COVID-19 as a crisis has been really important in building widespread recognition that individual action has common repercussions, community-wide repercussions. And those are really big lessons for us in the world where we are interested in environmental and earth sciences. So I think that's really important for us. As newly minted doctors, you are conveyed both privileges and responsibilities in terms of what you will do when you go out into the world. In an era of distrust, disinformation, fake news, we need you as our graduates to really stand tall for science, the institution of science. You're a next generation of experts, and given the newly bestowed authority upon you, you will be called upon to speak to issues of the day and to use that authority wisely. And I ask you that you be vigilant in communicating well-vetted and factual information from your own research or from credible resources that you invoke. I ask that you protect opportunities and venues where research can be undertaken free of political influence. I ask that you advocate for free speech and fora where we can communicate evidence-based factual information. All of these things are incredibly important to us, and I think today and into the future are things that we all have to be more vigilant about as members of this international scientific community. And last, I ask you to keep in mind that evidence and data are always reflective of the biases inherent in their own research designs, and they be reflective of the diversity of interests and experiences in our world. So a notion that we come into the exercise of the scientific enterprise with our own biases, and we have to be aware that they may not be representative of what happens elsewhere. So before we begin, I want to say congratulations to all of you. I'm excited to hear the stories that will be told today. I also want to thank Alexis, Rachel, Danielle, Mariah, Katie, Paul, and Lisa, who found a way for us to mark this moment with you and make it special even under these constraints. So I'm going to turn it over to Lisa. Thank you so very much.
Thank you, Toddy. So this is how it's going to work. First of all, I'm going to remind you to turn off your video and your audio if you're not speaking. We have 16 graduating PhDs. I think there's a list of them. There they are. And we have 16 people to move through. I was going to say 16 advisors, but some people have more than one advisee. So faculty, when you are presenting your graduating PhD mentee, please feel free to turn on your own video so that people can see you. And when you are being presented, graduating students, please feel free to turn on your video so that people can see you. Some students are not able to join us today, and we're going to talk about them anyway as we are recording this, and we hope that they'll be able to enjoy it with their friends and family later when it's convenient for them to do so. So you may not always see a student, and sometimes people may not have video capability. You have 3 minutes, faculty. You have 3 minutes to speak. At 2 minutes and 30 seconds, Rachel Lopiccolo will give you a signal. That will sound like this.
Ding, ding. Can't actually make it come up on command.
Okay, so that's the first part of our dress rehearsal that's gone awry. You will hear a ding, and it may just be that. And at 3 minutes, Danielle Wiggins is threatening to mute you for real. So please don't run out of time to say the final thing you want to say about your student, because Danielle says she will mute. Okay, the other thing is that please feel free, audience, you have a chat function in Zoom if you're familiar with it, and while the student you're interested in or your colleagues or peers that you'd like to congratulate, feel free to send chats in the chat function of Zoom to let them know that you're thinking about them. With that, we'll get started, and I am going to demonstrate the 3-minute speech while we do it. So the first student to be presented is Sarah Bess Jones Ziegler. I think we have slides. Sarah Bess is not here today, but her dissertation title is here, Marine Protected Area or Marine Pluriverse Area, a Political Ontology of Large-Scale Marine Conservation in Rapa Nui, Easter Island, Chile. So Sarah Bess came to us from the University of Georgia from an anthropology department. And as you can see from her title, her interest remained within the anthropological literature. She is interested in indigenous rights and ontologies or ways of knowing and understanding the world and how these intersect with marine conservation. She worked at this really iconic field site, Rapa Nui, or what you probably know as Easter Island in Chile, where the Chilean state was implementing 2 very large-scale marine protected areas in the waters surrounding Rapa Nui and a neighboring island. And she looked at the politics of that. Her dissertation is really theoretically and methodologically rich, and she takes really seriously the ethical obligations of anthropologists working with indigenous peoples. We often think about what we give back to the communities we study, and Sarah Bess has the good fortune of being an excellent musician, and with her mother fundraised and bought and took a cello to Rapa Nui for the music school, where she taught lessons to Rapa Nui students throughout her time there. At one point, her mother, a professional musician, visited and they gave a concert. So some of us are lucky in what we can give back. It really grounded her in the community, and the community really valued it. Sarah Bess did a lot of really interesting things at the lab. She led us in our thinking on the student side about diversity and inclusion. She ran workshops for us on LGBTQ diversity, on gender and sexuality, on gender violence, all of this with aging faculty. And she even gave us the joy of having a wedding ceremony on our dock at the lab. She is one of those students, like many of those who come through and spend time with us, who leave the lab a better place than it was when she first joined us. I'm sorry she's not here today, but I do hope that she watches this later and is able to celebrate this moment with her friends and family. There was no ding. Did you see that, folks? Okay, now as host, I will just cue that Javier Becerto, you're up. Can you please turn on your video and your audio and introduce us to Tasha? Tasha, also turn on your video if you're there. Javier was online and I saw him earlier, but we may have dropped, he may have had an internet problem and dropped. What should our protocol be, people? Should we move ahead and
I
come
can
back?
see him talking, but I can't hear him.
Oh, Javier? We can't hear you. Can anyone unmute him?
He
He
appears
shows unmuted,
unmuted.
so I wonder if he's using a different microphone than he's selected.
Here, let me.
Can you hear me now? Yeah.
Yes,
Okay.
Yeah.
Sorry about that.
that's okay.
Microphone. So Tasha came, as I was saying, came from the biology department at the University of California in Santa Barbara with an outstanding record that put her in an excellent position to become a PhD student in biology. However, she chose to come a very different path. She wanted to come to Duke, as she put it, to immerse herself in the social sciences and become fully transdisciplinary because, she said, you cannot do biology without taking into consideration issues of justice and morality. So for her PhD, she immersed herself in the social science literature on marine protected areas. Hype, as you might know, on marine protected areas is long-standing, but her dissertation studied a novel approach for marine conservation, fisheries refugia, which, as its name describes, are places where fishers cannot fish. And in this remarkable case, fishers have given the authority to choose where and when and the size of these places. So Tasha studied how fishers were involved along government and non-governmental organizations in the process of designing these areas. Tasha engages different literatures on collective action and political ecology, and her manuscripts explore from different angles how fishers, conservationists, and government can find ways to work together, cooperate, to move forward the agenda of fisheries refugia, despite the competing visions about coastal co-management these three stakeholders typically hold. One of them looks at the narratives, another looks at how fishers can gain a sense of ownership and property rights despite those resources and being told that they're not the owners of these resources. Tash has already published one manuscript, has two more in revise and resubmit, and two more that she will be submitting very soon. Right, Tash? During her tenure in our program, she has received several awards, most prominently the Anne Farrer Scott Public Scholars Fellowship, a first in our division, and perhaps the school, and a Bass Teaching Fellowship. I mention this because they reflect her other interests, teaching and public scholarship. If you know Tasha, you know about her interest in public communication and her keen ability to convey to others she's giving you her full attention. Two important skills, I will say, for public scholarship and teaching, for which she has also excelled as my colleagues and her students have come to appreciate. During her time in Mexico, Tasha engaged in a number of different activities for and with the communities she worked with that illustrate her interest in public scholarship. For instance, she took very seriously presentations about her preliminary results to community members, make sure she had their feedback and took it very seriously. She also made a point of attending the graduation of the first 10 students, mostly women, of the new high school in a community of 300 people in the middle of the desert in Baja California on the coast, as a show to support her support to these young girls. What I will hold most dear about my memories are my time in the field with her, during trips to the Gulf of California, the desert, her experience TAing my class, and learning how to mentor students in the field, how she threw herself to get to know the people of Baja California Sur, improve her Spanish in preparation for her field research, and where she made lifelong friendships. How she struggled with the Baja summer heat. As she said, I have learned how hard it is to think in the heat, she told me after spending the entire summer of 2016 interviewing fishers in these communities. Tasha, congratulations again. We will miss you.
Thank you, Javier. It seems so ruthless just to move on, but Deb Gallagher, you're up. So Tasha and Javier, yep, everyone's got it. Video's on. Excellent.
Thank you, Lisa. I have the distinct pleasure of talking about Sean Lundquist, who I've been working with for 5 years and I will miss very much. This isn't Sean's first go round at Duke. He graduated from Duke Law School in 2007 at the beginning of the Great Recession. So I think he's got some tough skin out there to put into the world right now when we're facing uncertainty. And Sean came to us at the Nicholas School into the Environment PhD program to think about how his fascination with how people perceive risks. After law school at Duke, he went to a law firm in DC for a number of years. He didn't really like it. So he was so interested in coming and really engaging in deep thinking, but also integrating concepts from social psychology, from legal theories and concepts, as well as environmental public policy. And so that's what he started doing when we started our work together. He's really a brilliant and creative integrative thinker, and it's been my pleasure. Some of the most important times together, we're just sitting in my office just talking for hours and hours about how to integrate these concepts. He was interested in how risk perceptions had an influence on legal outcomes, toxic tort outcomes related to fracking. That was what he was really focused on. But he looked at it through 3 different lenses: from public policy, from legal theory, and from social psychology. And so to gather his data, he was doing an exploratory study, social science study. He went to the hills of Western Pennsylvania and spent times in bars, in coffee shops, and in people's homes with exploding, I guess, water. The water faucets would explode from methane gas from fracking. At least that's what they told him. And he gathered incredible amounts of interview data and was able to integrate these data into a really nice theory of how risk perception has an influence on a number of different topics. He has 5 papers out there in the world we hope to get published. I'll talk about a couple of them. One looks at risk perception on the fairness of toxic tort claims related to fracking. Another one looks at how public policies related to information disclosure can help uncertainty in risk-based decision. And then just a basic sort of theoretical paper about how risk perception can influence fracking-related decision-making. But I'd ask that you think about one of his papers, which I think is really amazing and brilliant, and that is he tied together, non-disclosure agreements became a really important concept, tool in risk perception and the fracking. And he began to think about what was the role of non-disclosure agreements. And so he has this wonderful paper about is called Non-Disclosure Agreements and the Unlikely Convergence of Sexual Harassment and Fracking Toxic Tort Claims. So how you can tie the Me Too movement together with fracking. So I encourage you to talk to Sean about that, because it's pretty controversial and pretty brilliant. And I don't know how much time I have left. I got a ding, but I want to say it's just heartbreaking to not be able to be there with Sean. I promised Andy I would cry. I am crying, and I hope someday, it's my absolute fervent hope and dream, Sean, that we can be in the same room and share a glass of champagne together, because I will really miss you. Oh, one more thing. I want to add one more thing. He taught an online course in the Dell program, so he's really armed to go out there in the world right now.
Thank you, Deb. Congratulations, Sean. Next up, we have Pat Halpin. There you are.
Well, I'm not the star. It's Guillermo.
That's your job.
Okay. So for me, today is a truly significant day for soon-to-be Dr. Guillermo Ortuño Crespo. I think also for our lab and for the field of global fisheries science and governance. This week, Guillermo is formally entering the professional community as a fully fledged and well-established scientist and leader. And I want to underline the point that while he is formally making the transition from PhD candidate to credentialed PhD scientist, he has already been recognized as an impactful leader in this field for a number of years. Guillermo has been on a remarkable trajectory since he first arrived at Duke. Guillermo's first encounter with Duke was actually at a summer course at the Duke Marine Lab, where he became really intrigued with our multidisciplinary approach and later applied to become a PhD student with the Marine Geospatial Ecology Lab. He's been a true believer and supporter of Duke's mission since day one, and we look forward to continue our working relationship for many years to come. Guillermo has come to us wanting to work in the combined fields of fisheries ecology, ocean governance, and dynamic ocean management. And it's an enormous and ambitious scope of developing interests, skills, and expertise. So he really bit off a huge chunk. And Guillermo has achieved and surpassed all expectations in this multidisciplinary training. So Guillermo's work and impact, Guillermo spent the last several years providing scientific inputs directly into the policy, management, and governance arena. Guillermo's published a number of papers and has many more in the queue. Guillermo has split his time between spatial modeling, UN ocean governance meetings, and working with fisheries management organizations. So really, truly taking on the multidisciplinary aspects that we encourage at Duke. Guillermo holds his own in scientific meetings, fishery management meetings, as well as the corridors of the UN. This is exactly the type of multidisciplinary research we aspire to at the Nicholas School, and I think he's really shown us well. Guillermo's research work primarily focused on the analysis of global fisheries in areas beyond national jurisdiction, or commonly referred to as the high seas. His work is focused on developing new tools and analysis to better inform dynamic ocean management in these ocean commons. To conduct this effort, he spent significant time both conducting fundamental research science, but also communicating the science directly to policymakers and stakeholders, the UN and other governance bodies. During his tenure at Duke, Guillermo was an active Nereus Future Oceans Fellow, representing a group of rising PhD and postdoctoral researchers specifically selected to work across disciplines on global ocean issues. One of my most descriptive memories of working with Guillermo was the multiple times we found ourselves distributing the latest scientific papers or policy briefs directly on the desks of negotiators at the UN, and really inserting new relevant science directly in the policy arena. Before finishing his PhD, Guillermo has been selected as one of 4 early career ocean professionals for the UN Ocean Decade of Science for Sustainable Development. And that's quite an achievement and bodes very well for his continuing impact in the field. Guillermo will be moving forward to work as a postdoctoral research associate with colleagues at the Stockholm Resilience Center in Stockholm University, and will be continuing his active work on dynamic ocean management and promoting more effective management of fisheries management organizations on the high seas. Guillermo will continue his relationship with our lab and the High Seas at Duke initiative, specifically to continue his work on high seas governance at the UN. Congratulations, Guillermo. We look forward to our continued work with you into the future. Great job.
Thank you, Pat. Congratulations, Guillermo. Lovely. Next up on the agenda, Jim Heffernan and Catherine. You guys could turn on your... Okay, we have you both. Great.
Hi, everyone. I'm really excited today to be, and proud to be introducing Dr. Catherine Chamberlain. Kathy defended in late March, among the first at Duke to do so remotely. Kathy received her BS in chemistry from Yale in 2012 with her undergraduate thesis focused on the development of isotopic proxies for paleoclimate reconstruction. After graduating, she taught English in Russia and then returned to Yale as a postgraduate researcher studying molecular biology, including the regulation of circadian rhythms. Kathy began her PhD at Duke in 2014, and while she's been here, she's been supported by a James B. Duke and a National Science Foundation Graduate Research Fellowship. She's also taught a number of classes. Kathy is the author of 2 papers from her undergraduate and postgraduate work, and is the lead author of 2 papers from her dissertation, or at least from her time as a graduate student. The first published in the Geosciences journal, Earth Surface Processes and Landforms, and one of the central papers of her dissertation published last year in the journal Ecology. So what Kathy's work does is ask in ways and at scales that no one has ever done before, why river chemistry changes over the course of a day as plants and animals shift their activity in different ways between daylight and dark. Her work focuses on the essential element nitrogen, which is both necessary for organisms to grow, but also a really important pollutant due to over-fertilization. So in the first, in one chapter, the one that's published in Ecology, Kathy used experiments to show that the ways that nitrogen concentrations go up and down from day to night can tell us whether nitrogen is actually the limiting resource in that environment, in that stream or river or lake. And so to do this, Kathy ran a really challenging greenhouse experiment that had her up at all hours for several weeks. So in some ways, she's continued that, she's leaned on that, the hard-won experience that she had in those molecular biology labs. And those experiments are going to help us interpret and understand high-frequency data in ways, and apply high-frequency water chemistry data in ways that we have not been able to use them before. So one of the things that's really incredible about Kathy's work is that in addition to these greenhouse experiments that were extremely mechanistic and extremely hands-on, she also examined these massive data sets that she assembled from established sensor networks to understand how nitrogen chemistry changes in many rivers at the scale of the entire United States, or the entire sort of North American continent. And in that work, she showed that some rivers have consistently higher concentrations during the day, others consistently higher nitrogen concentrations at night, and still others show very different patterns at different periods of time. And so we think that these patterns are going to help us understand what the pollution processes are that vary in different kinds of rivers. So in order to do that, Kathy had to develop new analytical techniques. And so this incredible breadth of approaches and scales at which Kathy worked is always going to mark to me the ways that she's contributed. She's, I think, the world's only self-identifying circadian biogeochemist, but now that she's done and ready to go out into the science world, I think there's going to be a lot more people following in their footsteps. Congratulations, Kathy.
Thank you, Jim, and congratulations, Kathy. The next up, we have Jim Hench and Melissa Duval, and I see Jim. I don't see Melissa.
Can you guys hear me?
Yes.
Hello? Okay. Okay, Melissa was online earlier.
Yep, I'm here.
Oh, okay. Okay, well, here we go. Let's see. Let me start by giving a little background. Melissa came to Duke from the University of Maryland for her undergraduate and her master's degree from University of Virginia. And at Duke, she built upon her master's work looking at wave propagation over tidal flats and salt marshes. And here with us, she pivoted over into coral reefs and examined a set of questions exploring the interactions between multi-scale flow and multi-scale reef topography. The structural complexity of reefs is conceptually easy to imagine, but present methods and metrics for quantifying complex topography are limited. Moreover, reefs are embedded in wave and tidally driven flows, such that the interaction between the topography and the flow is also poorly understood. And so making progress on these questions in this topical area is important to think about, since coral reef communities depend on both their topographic properties as well as the flows for their survival in different ways. So in Melissa's dissertation work, she had this wonderful amalgam of making truly unique field measurements of topography and flows, which included 2 one-month field campaigns at a reef down in the South Pacific. And this work yielded some data sets that we believe are the most detailed view yet of multi-scale flow over coral topography. But even more important than those amazing data sets is Melissa's development of a conceptual framework and the mathematical ideas and tools to analyze those data. And let me make a brief aside and point out that prior to Melissa's dissertation, the most common metric to quantify coral reef topography was something called rugosity, or an index of roughness. And this is something that's gotten quite a bit of traction in the literature. We found last year alone, only in the coral reef literature, this concept was used in 400 publications, a little over 400 publications. And in Melissa's first chapter of her dissertation, she demonstrates that this is a fundamentally flawed concept, which would allow markedly different reefs to have identical rugosity values. And so Melissa wrangled this interesting problem using some creative ideas about how we can actually quantify the horizontal and vertical length scales of reefs. And so her first chapter had was published in JGR Oceans, and showed that corals are not only fractal but also multifractal, that their variability not only varies with scale but also with location. And we expect that paper to make a big impact on the field. And as if that wasn't enough, she's got 2 other outstanding chapters. The second one, which is all but published now at JGR Oceans again, and extends some of those ideas into 2 dimensions, and also points out that the drag on the flow is represented in different ways that account for the spatial statistics of the roughness. So we expect Melissa's work to make a sort of an advance in this area. And as Tati was pointing out in her opening remarks, this is a place where work kind of ripples outward from Duke, as reefs are some of the most important and diverse ecosystems, but also some of the most threatened by environmental stress from climate change. And Melissa and her work, I think, bring a very much needed physical science perspective to these problems. And hopefully some of these things will be adopted before too long to help think of ways that we can conserve reefs, guide restoration, and improve predictive models for the future. Let me end by just saying it's very sad for me to see Melissa's time at Duke wind down. I'm confident we'll continue to interact through the years, and I'm looking forward to that. And with that sadness to see her go, it's also at the same time exciting to see that she's lined up a nice postdoc, an ORISE postdoc fellowship at the Environmental Protection Agency's Office of Research and Development at their Center for Environmental Measurement and Modeling. And I'm expecting great things to come of that. So thanks, Melissa. It's been really wonderful, and congratulations.
Thank you, Jim. Congratulations, Melissa. I can't see you, but I could hear your voice. Next up, we have Joel Meyer. He's got, we're going to go through 2 students first with Latasha Smith. And Latasha, if you're there and you want to turn on your video, you're welcome to.
Thanks, Lisa. Latasha is unfortunately not going to be on the video, but she and her family and friends, I think, will be watching it. So I'm really pleased to have the chance to talk about Dr. Latasha Smith and the wonderful work that she's done. Dr. Smith was born and raised in Eastern North Carolina. She earned a bachelor's degree in biology and marine biology, magna cum laude at the University of North Carolina, Wilmington. She was recruited to Duke by the Pharmacological Sciences Training Program and awarded the prestigious and competitive Dean's Graduate Fellowship and Chancellor Scholarship. In the Pharmacological Sciences program, students do rotations and then choose a lab, so I was very fortunate that she chose to join my lab after several rotations. She's really been an outstanding researcher and lab citizen. She has routinely taken time from her work to engage in a variety of within Duke, as well as outside of Duke, supportive groups who are underrepresented in science. So I'd like to tell you a little bit about both her research and her work outside of lab. Her research was focused on understanding how damage from pollutants to mitochondria could lead to neurodegeneration, specifically of a population of neurons called dopamine neurons. And this is important because loss of these neurons is characteristic of Parkinson's disease. And while most Parkinson's disease results from environmental factors, we have very little understanding of what those factors are. And it's a challenge to test because there are literally tens of thousands of chemicals out in the environment, and making testing of those a very daunting process. Latasha contributed significantly to our understanding of the processes contributing to mitochondrial damage and dopaminergic neurodegeneration, as well as really advancing our understanding of how to test them, looking in particular both at morphological breakdown of some of the neurons in the brain region of a worm model that we use, and also behavioral outcomes in those worms. From that research, she has published one first author and 3 middle author papers with another in preparation. I want to mention she's also been an exceptional lab citizen. She's been very generous with supporting others in the lab with scientific knowledge and methods, although she is extremely, Latasha, reluctant to ever ask anybody else for help. She also organized the entire lab to handle lab maintenance tasks during a time when we were missing a lab manager. And Latasha, you really did that in a very fair way that everybody was comfortable with, and that I think was remarkable. In another example, although not technically a Nicholas School student, Latasha has a very strong environmental conscience, and that is exemplified by having written and won a grant to initiate a program of recycling of laboratory gloves, which we go through quite a few of. I'd also especially like to applaud her STEM and minority STEM outreach activities. Dr. Smith is a member of the Lumbee tribe, and as such familiar with the difficulties faced by many groups who are underrepresented in science. So she brings a really powerful perspective and voice to such work. Furthermore, her decision to engage in that way is particularly admirable from a personal perspective because Latasha has a very quiet and private nature and is not naturally inclined at all to any kind of public event. Actually, that is an enormous understatement. She hates public attention. So I especially appreciate and applaud her work in such events. She received several job offers, and I'm thrilled to say that she's taken her exceptional intelligence, attention to detail, and critical thinking skills to the EPA, where she's employed as a biologist and risk assessor. Latasha, I very much appreciate the work you did in and outside of the lab during your time at Duke, and know that you will do an outstanding job helping protect our country's environment at the EPA. We'll miss you, but we're glad that you're doing what you're doing, and we wish you the best. Thanks very much.
Thanks, Joel. I'm sure she'll enjoy listening to that later. We have a second student, thank you, and a second advisor. Susan Murphy, is she on today?
She is, I saw.
Oh, there, great. Thank you.
Great, okay, well, so introducing Dr. Rashmi Joglekar. Dr. Joglekar earned bachelor's degrees in both vocal performance and biotechnology with a minor in chemistry. Her GPAs were 3.99 in music, but a mere 3.98 in biotechnology. Despite having clearly slacked off in her science courses, she came to Duke to pursue a PhD in toxicology and environmental health. In this program, students first rotate among 3 labs and then choose which lab to join. Rashmi joined both Susan Murphy's lab and mine, so we'll both be saying a few words about her. Because her work ended up more squarely in the Murphy lab than mine, I will say more about her activities outside of science, and Dr. Murphy will describe her exciting research. Rashmi's goal has always been to take her knowledge of science into the realm of policy and politics, and fitting with this, she has a truly exemplary record of service and leadership. She served as a mentor for the Elementor program for the R.N. Harris Elementary School, was co-founder of the Campus Pantry Collaborative funded by the Keenan-Biddle Partnership Grant, student leader of the Duke Smoke-Free Leadership Council, grad student representative to the University Hate and Bias Steering Committee, the University Priorities Committee, the Duke Alumni Association Board, the Duke Student Alumni Board, and several Duke Board of Trustees standing committees. She also served as representative, vice president, and president of the Graduate and Professional Student Council, GYPSY, became a member of the Durham City Council and County Environmental Affairs Board, and did really wonderful work with the Duke Environmental Law Clinic to help protect North Carolina children from lead exposure by interacting with policy and lawmakers. That's an abbreviated list, so you won't be surprised to know that she was chosen as one of the Duke Chronicle's top 18 people to know on campus in 2018, and just today was awarded the Duke Alumni Association's 2020 Forever Duke Student Leadership Award. Congrats, Rashmi. Throughout all of this, she also worked very hard in the lab, and Dr. Murphy will tell you about that wonderful research.
Thanks, Joel. Rashmi's thesis research was complex and involved both studies in humans and in animals. She has 3 manuscripts coming from this work. Her results have helped us better understand the impact of tobacco smoke exposure on the mechanisms by which genes are regulated in children. She's contributed to knowledge about brain development, more specifically how tobacco smoke exposure during pregnancy in rats can alter the trajectory of brain sexualization and then alters sexual behavior in the adults. Rashmi didn't escape scrutiny from locals at the coffee shops who glanced suspiciously at her while she was scoring these rat behaviors from many hours of recorded videos on her computer. Rashmi's project is not easy to describe succinctly, with concepts like epigenetic programming, bisulfite pyrosequencing, preoptic area of the brain, osmotic mini pumps, and metastable epialleles, but she managed to wow the audience in the Nicholas School's PhD Symposium 3-minute thesis competition and took first place. She also received a distinguished poster award from the Environmental Health Scholars Program Fall Program and was a AAAS Science Program for Excellence in Science awardee. These are just a few of the many accolades she's earned and deserves. On a personal note, Rashmi is genuinely kind, funny, and a lot of fun to be around. She was and will always be a treasured member of my lab, and my lab and I will miss her deeply. We knew she was destined for big things, and she's already on her way. Within weeks of her dissertation defense, Rashmi was offered her dream job with Earth Justice. Their catchphrase is, "We are here because the Earth needs a good lawyer." This perfectly encapsulates Rashmi's desire to effect change and improve the human condition and the world we live in. She's working as a staff scientist in the Toxic Exposure and Health Program and is based in their Washington, D.C. office. Rashmi, congratulations to you and all that you've accomplished at Duke. We are proud of you and wish you nothing but the best in your new career. Thanks.
Thank you, Susan and Joel, and congratulations, Rashmi. We're halfway through and I'm just kind of overwhelmed by the accomplishment of these people. So let's hold tight for the second half. Brian McGlynn is somewhere in the dark, possibly in the light now. And John Fair, we have a visual. Take it away.
Yeah, the sun is rising. North Carolina native. This is for John Mallard. John's a North Carolina native with an undergraduate degree from the University of North Carolina. He moved to Montana in 2007 and came to see me when I was a professor there in Montana and requested to volunteer in our lab. Instead, I hired him and we've been working together ever since. He completed his master's degree at MSU focused on stream network hydrology. And after our lab moved to North Carolina and Duke, John decided to come back home and move to North Carolina. Even though he's a diehard Tar Heel, he agreed to do his PhD at Duke and rejoined our lab there. John has numerous published papers and dozens of presentations around the world, and is highly regarded in our field already, despite his early career status. He's a hydrologist focused on how rainfall becomes stream flow and how watersheds store and release water. John's been instrumental in the success of his fellow students and me, and we all owe him a debt of gratitude. I feel extremely fortunate to have worked with him, to know him, and to have him as a friend. And John, you have my strongest congratulations, and I'm proud of your accomplishment.
Thanks, Brian. Thanks for getting up so early too. Congratulations, John. Next, we have Andy Rigg and Will Kofi.
Thank you, Lisa.
You're welcome. There you are.
Here I am. Dr. Will Kofi was born into a family of intellectuals and teachers in New Hampshire. With a natural gift for teaching, he could have pursued a career teaching biology and being one of those instructors who had a profound influence on generations of students. Or, due to his love of the water and old boats, he might have decided to be a fisherman and developed an encyclopedic knowledge of the sea. But we're fortunate that he chose to combine his gift for teaching and his love of the sea with his passion for research. Will's initial dissertation plan was to study biomarkers in fin whales as a way to gain insights into their ecology and feeding behavior. But he's such a superb field biologist, I lured him to participate in our long-term field study of Cuvier's beaked whales off Cape Hatteras. That's the species you see in the picture and also the species you see behind me. Cuvier's beaked whales are a fascinating but poorly studied species of whale that live in deep waters far from shore. And so in the third year of his PhD, Will switched his project to a study of the social behavior of Cuvier's beaked whales. These are the greatest mammalian divers, routinely reaching depths of 2 or 3 kilometers to feed near the sea floor. Think about being able to do that on a single breath of air. They spend very little time at the surface, which made Will's study of their social interactions particularly challenging. To give you a sense of the scope of his problem, during the entire 90 minutes we're together this afternoon, a beaked whale might spend only 2 or 3 minutes at the surface where we can see them. So to meet this challenge, Will wove together a diverse set of research approaches. He equipped some of his study animals with electronic tags that transmitted data to orbiting satellites and followed those individuals for weeks. He collected tiny tissue samples using a remote biopsy sampling technique and determined the sex of these animals using molecular methods. And he took thousands and thousands of photos to identify individual whales to see who was associating with whom. His dissertation has painted a rich and surprising picture of the social lives of these whales and really established a new standard for those who are going to come behind him who want to work on these enigmatic animals. Studying beaked whales means spending a lot of time in a small boat waiting for your study animal to surface. So Will and I have had a lot of time to talk about whales, of course, but also about politics, about seabirds, science, food, fishermen, boats, particularly Will's dislike of the look of Carolina charter boats and the clear superiority of New England lobster boats. Those pretty days in the deep blue waters of the Gulf Stream will be some of my fondest memories of our time together. Will is poised for a great career as an academic scientist. He has a remarkable portfolio of research skills, from handling a small boat to writing code to working at a lab bench. And as I mentioned at the outset, he has a great gift for teaching. So we all expect great things from him in the academy. Will, I want to thank you for taking me on this journey with you. I've enjoyed every minute of it, and I've certainly learned much more from you than you have from me. Good luck with your next steps in the journey, and congratulations.
Thank you, Andy. Congratulations, Will. Next up, we have Drew Schindel. And Drew, you have 3 students, so I will invite you to transition yourself, if you like, between them.
Will do my best.
Okay, great. And we'll start with Alan.
Thanks, Lisa. So first I'm going to talk about Alan who has completed his master's this past year with us, looking at seasonal and interannual variations of aerosols over the Amazon. I don't believe Alan is joining us today, but maybe we'll be able to watch later. Alan came to us from Tsinghua in China, and his work here was done with me as his advisor, also with Prasad Kasabatla from Environmental Sciences. And what he worked on was looking at analysis of both in situ observations and remote sensing observations to explore biomass burning over the Amazon, how this was represented in 2 different models developed by NASA and the academic community, and how those models compared with observations. The overall goal was have an eye towards improving our understanding of the role of biomass burning in changing the composition of our atmosphere, both how that would affect climate change and how that would contribute to public health. He ended up learning quite a lot of new coding to deal with these data sets. Both the climate models and the remote sensing in particular are enormous data sets, and this was something he had to develop experience with. He was a very diligent worker and was able to successfully manage to deal with these very large data sets, which is quite challenging. We're happy to see him moving on, having completed his master's, to pursue the next stage of his education. And I think I can say on behalf of both Prasad and myself that we're very happy for him and looking forward to seeing what comes of his future work. I am ready to transition. Thank you. Super. Thanks for advancing. The next student is Dr. Carl Seltzer, who was actually the first PhD student I've ever had in my career. So that was momentous for me in particular. Unfortunately, Carl put up with my being a novice advisor and studied long-term ambient ozone exposure, magnitude trends, and impact. So Carl came to us from the University of Florida in Gainesville. He spent a little time at the EPA here in Research Triangle, so was familiar with the area before coming to join my group at Duke. While he was here, he spent, of course, most of his time at Duke, but he also went off to the International Institute for Applied Systems Analysis, a worldwide center of excellence in all kinds of complex problems, including many environmental ones, that's located just outside Vienna, and was a summer research fellow there and a nice, prestigious and difficult to get fellowship there. While here, he was first author on 3 papers, co-author on 2 more, and is contributing to 2 ongoing studies that were still in progress. And his work was really to explore the basic understanding of atmospheric composition, how we model that, how we measure that, how we evaluate models given limited data, and how we can improve our ability to both model and infer areas where we lack observational capabilities. The idea and the goal and what he really achieved was better understanding of exposure, how exposure levels are understood, again, based on models and measurements, but also their impacts and what they do to human health, what they do to composition, and what they do to climate. He's really covered a wide-ranging area, and his most recent paper actually went into using artificial intelligence, collaborating with some people in other parts of Duke to develop these machine learning algorithms. He's collaborated with colleagues across in the United States, but also in the UK and China on several of his papers. The other thing I wanted to mention about Carl is he filled in for me in both my undergraduate and graduate classes and received rave reviews from my students. I think he has an excellent future in education, but he has taken a job at the EPA here in Research Triangle Park. So at the moment he's gone to government instead to help their understanding of complex organic aerosols and how they likewise affect climate and health. But we're glad he's nearby and can keep working with him. Finally, during his time at Duke, Carl both got married, and he and his wife had a baby daughter. So we're really grateful to have been able to share in those important parts of his life. And while we'll miss him, we're glad that he's nearby and can keep in touch. Congratulations, Dr. Seltzer. I can transition to Dr. Tang, please. Here we go. Forcing prediction and cloud responses to individual forcing agents was the topic of Tao Tang. Now, Dr. Tang's research during his time here at Duke. Tao came to us after getting 2 degrees, a bachelor's from Beijing Forestry University, and then a master's from the University of Hong Kong, both of course in China. He came here and worked on, as you can see, these issues of forcing, but more than that, he worked on understanding atmospheric dynamics, understanding how the different things that human activities throw up into the atmosphere cause changes that are maybe not so straightforward to understand, and there's a lot more to it than just global warming that we all hear about. So one of his most interesting papers was looking at the response of precipitation around the Mediterranean and how that changed depending on which agent was driving climate change, and how it was not necessarily proportional, this regional rainfall change, to the global mean temperature change. Another of his papers was really how we understand the radiative forcing, which is a measure of the energy imbalance that drives climate change, and how that's really subject to how we measure it. And there's a lot of uncertainties and different ways we can explore that. That came out in JGR, Journal of Geophysical Research, for those who are not so familiar with our lingo. And to Tao's credit, that paper that came out last year is one of JGR's top downloaded papers from their last 2 years of publication. So it's really very well received work. He also presented some of this work at posters, last AGU meetings, both in Washington and New Orleans, gave some oral presentations at project meetings, 2 of those in the UK. And all of these were very well received. So we've been very fortunate to have Tao come and work with us and do some really interesting physical science work, and looking forward again to seeing the next stages of his career. Thank you.
Thank you, Drew, and thanks to all 3 students. Congratulations, Tao. We'll transition now to Brian Silliman.
Okay.
Stacy's got her video on, so you're set, Brian. And
okay, great. I just changed so it wasn't dark. So, hi, Stacy and your family, and hi, everyone. I'm really excited to honor you and your successes that you've had here at the Marine Lab and the Nicholas School today. And now Dr. Stacy Zhang first came to Duke from University of North Carolina, and I first met her when I was organizing marine biology meeting at University of Florida. I was grading best student awards, and I came to the judging ceremony. I said, this is the best student. We got to give this PhD student the award. And it was actually, they said, you can't do that because she's an undergrad. So that was Stacy Zhang, and that's the first time I met her. It was gave just an outstanding talk. And at Duke, that excellence has continued. She's excelled not only in academics, but also in teaching and leadership at a much higher level than most graduate students attain. And for example, in outreach, Stacy, you've been an inspirational leader to faculty and students in the Marine Lab's effort to take learning science through experiments and observations into elementary classrooms through our outreach Siren program. And in teaching, you've just been outstanding in all accounts, and would have an amazing career in there if you decide to go that way. And you inspire students through outstanding lectures, enthusiasm, creative thinking, and Stacy just wasn't a teaching assistant. She was a co-instructor on this field course I taught. And she would give a lecture, like if we were cramped down because of weather, I would say, is it possible you can give a lecture on this topic tomorrow? She said, sure, let's try to put that together. And she would just give an excellent one. She was always courageous, leading us through the jungles. When we had to go through the cave, she was first to go. And the students always looked up to her for encouragement and leadership. And for her dissertation, again, her excellence continued. She wanted to test the application of theory and positive interaction through corporations and how that applied to seagrass ecosystems. One of her loves is to be in seagrasses. And she wanted to look, what are the importance of these partnerships to biodiversity in seagrasses and their functioning? And what happens if you stress out the system? Does that increase over time? And she found really important things. She used very intricate mechanistic field experiments and large-scale studies to answer questions, and led a team of 2 or 3 undergrads each summer, almost completely by herself on the boat daily doing this work. One chapter showed that she found that a mutualism between seagrasses and clams actually creates hotspots of biodiversity that then affects function and nucleates out in these seagrass beds. And then she did large-scale experimental studies manipulating predators and showed that they had big effects on these clams. And the last part of her dissertation was she went into the literature and said, these are powerful, positive interactions that can change the course of these ecosystems. Are people using them in restoration? A massive undertaking. She found that they weren't in the restoration literature. And lastly, she incorporated them in the designs. And she started planting seagrasses with clams, the seeds of seagrasses with clams, and got 400% increases in some cases. And I really think those changes, when implemented across global scales, are going to make a huge difference, Stacy. And it's going to be like planting legumes with corn, like Native American Indians did, and it'll change that. So you've been very successful, 7 publications in your dissertation, and you already have an NSF postdoc. I would say exceptional academic and exceptional person. You're much loved by the Marine Lab community, the Nicholas School, and the Silliman Lab. And thank you for doing your dissertation with me. And I'm so proud to know you as a person and super proud to know you as a scientist. Congratulations.
Thank you, Brian. Congratulations, Stacy. Next, Cindy Vandover, and I think we have Philip on. Oh, there he is. I'm not sure what time zone he's in, but here we are. Take it away, Cindy.
I will. Oh, there you are. I'm just looking for his video. There I was staring at his name all the time. Hi, Phil. So it's a pleasure to be here to celebrate with Dr. Turner, his accomplishments at Duke, and to do that with his family and friends and colleagues. He is, as you can see from this picture, he's been diving in Alvin, or you get the sense that he might dive in Alvin, the submersible. He's maybe distinguished among the honorees here at having dived multiple times to the bottom of the sea. His PhD research topics, it's been fun to watch his thinking evolve. He's published on just the fundamental ecology of a deep sea quillworm, one of the creatures we saw on the seafloor and got curious about. So while we were on the cruise, in addition to the other things we were doing with samples, we wrote a paper about that quillworm. So that was an adventure in writing and exploration. And then the work we did off of North Carolina, he really took the lead on the characterization of the seep sites that we visited. And his work led us to think more about how seeps contribute to the life history stages, life history activities of commercial fisheries or commercial organisms, in this case, a crab. He also did some work on functional diversity in deep sea ecosystems using archive data, which should be pretty exciting. I think that's still in the works to come out. And he's joined us, me and Pat Halpin and others, Daniel Dunn, thinking about spatial management in the deep sea as we come into this, what is likely to be a new era of deep sea mining. So he's also written about deep sea ecosystem processes and services and valuation. So you can see he evolved. He drank the Kool-Aid. He's evolved from just thinking about basic science and ecology to thinking about other aspects of how we work in these systems and think about environmental management. And probably one of the most interesting things, those of you who saw his dissertation presentation, he spoke of his chapter commemorating the Middle Passage on the Atlantic seabed. That paper is just submitted. He just submitted that to Science Policy, so we'll see how that goes. And he has, as one of his co-authors, His Excellency Dr. Kanu from the Republic of Sierra Leone, who's very interested in following up as once this work comes out, the ideas come forward, and working with Phil to bring these ideas in some kind of action from the International Seabed Authority. So Phil is an international scholar. Over the years, he's built a large network of peers, colleagues and leaders in deep sea environmental management, and through his work with things that the International Seabed Authority is tackling. It's one of our missions is to train the next generation of leaders who integrate social, natural, and conservation sciences and connect science to action through research that informs policy. And I think Phil, like many of the others we've heard about here, he's emerged as one of those young leaders. So I couldn't be more proud.
Thank you, Cindy. Congratulations, Phil. We are last but certainly not least, we have Erica Weinthal, there she is, and Farah, there you are. Take it away, Erica.
Okay. I guess everybody sees me okay. Yeah. So I have the pleasure, I guess, of being last and being able to congratulate Dr. Farah Hagezi, who actually finished up in the fall and is someone I've known for a very long time because she first came to the Nicholas School in 2009 to do her MEM with us. And at that time, she did an amazing master's project on cooperation over water in the Nile Basin. And I really got to know Farah back then. And, you know, while she has been a student of mine for quite some time, with some time off, she's also a friend, she's a colleague, and I would consider her family. She came to the Nicholas School before that from McGill, and as you'll also see with the nature of her work, she is a global citizen. She is originally, she is from Egypt and has focused on international water, on issues of environmental security, on the politics of water and sanitation provision, and political institutions. After she finished her MEM, she went on to be a researcher, a junior research scientist at the Center on International Cooperation at NYU. And what was really special about this position was in a random meeting, she was talking to my former dissertation advisor, who was really her boss in some ways. So this was an extension of the family. And over the years, the three of us have gotten together at various times. And it's just been wonderful to sort of have this world grow and network grow. At Duke, she did an amazing dissertation on authoritarian governance and the provision of public goods, looking at water and wastewater services in Egypt. She did this at a really challenging time to do international field work with the revolution, the Arab Spring in Egypt. And she persevered. She wrote an excellent dissertation looking at this transition from authoritarianism to procedural democracy. And again, just lots of political turmoil and how that affects the way that governments provide public goods, public services. This is something that I think is extremely relevant, the lessons about what is the role of government, something that we should all be thinking about. But she also was able to translate a lot of this work into a local domestic context in Alabama, looking at the provision of wastewater services in Alabama too, in a project that she helped lead with the Duke Human Rights Center. The fact that Farah was able to finish in the fall meant that we were able to celebrate and toast with her, you know, in the fall, to, you know, drink champagne. But what was more meaningful was that her father was able to be at the defense. He was there from Egypt. Her aunt was there, other friends of the family. And so we did have a celebration, which was fantastic. And I know they're all, you know, wanting to celebrate again. What I want to say, Farah has ended up, I think, in the most perfect position that one could find. She is now a researcher at the Stockholm International Peace Research Institute. She is working in their climate change and risk program. And she brings her knowledge of the Middle East, climate policy, water policy to CPRI. And so I think what we all want for our PhD students is for them to end up in the world and to have impact. And I am entirely confident that Farah will continue to do that. So with that, I just want to say congratulations to Farah. Congratulations to all the other PhDs today. Thanks, Lisa.
Thank you, Erica, and congratulations, Farah. That's really just such a spectrum of excellence that it's been a delight to listen to everybody's stories of their students. We always think we should open it up for the students to tell stories about us, but that's for another day. I'm going to turn it over now to Andy Reed, who's going to say some final remarks. And I just want to, again, before I do that, to thank the staff of the Nicholas School who worked hard to put this together. And I hope that friends and family have enjoyed it, even in this mediated remote Zoom world. Andy.
Thank you, Lisa. I'm going to make a very few brief concluding remarks. And at the end, I'm going to offer a toast to the graduates. So if you are so inclined, it's time to uncork that bottle you've been keeping on hand and pour a glass of something festive, because you're going to need it in about 3 minutes. Let me begin my remarks by stating the obvious. Doing a PhD is really, really hard, which may explain why we academics celebrate new PhD graduates by dressing up like we are all at Hogwarts. I don't know, but that seems likely. For most of us, the PhD degree is the most immersive, the most challenging, and hopefully the most rewarding intellectual experience of our lives. And no, graduates, that does not mean that it's time just to put on a smoking jacket and slippers and call it a day, although I don't expect any of you to do that. We ask our PhD students to tackle a really complicated question that no one has addressed before. And you've heard just a beautiful spectrum of examples of that, right? Just incredible. And to tackle and to advance our understanding of the world in a way that nobody else has ever done. And I just, again, the diversity of approaches and questions that our brilliant students have taken to push back the frontiers of knowledge is just really impressive. But of course, this process is not just intellectually difficult, but it's emotionally challenging. A PhD is 5 or 6 or 7, as Lisa alluded to sometimes, a 7-year journey with many twists, turns, and setbacks. You might remember the brilliant research question you woke up with in the middle of the night, only to discover that it was answered in an obscure paper published in 1975. You might remember the experiment that failed and failed again. The challenges of coding the 100th interview in vivo. Your advisor's peculiar inability to comprehend the beautiful logic that's contained in the penultimate sentence of paragraph 3 on page 147 of your final draft. And then finally, you submit your favorite chapter for publication and find out that you have to deal with the comments of reviewer number 2. What the hell is with that? But fortunately, you've had a lot of help and support to get you through the dark times along the way. Hopefully, your advisor and committee have been of some help, or at least got out of the way and let you do your work. But it's really the other people on this call who have been important. Your family, your partner, your friends, your dog, your cat, your cohort of students, the people who ensured that you made it across the finish line. So thank you to all of you who helped our students make it. Under any circumstance, completing a PhD is a truly remarkable achievement. But some of you completed your degree under truly extraordinary circumstances. In the midst of a pandemic, you finished writing your dissertation on your kitchen table. You defended your dissertation over this weird interface we call Zoom. And then maybe you celebrated with a Zoom party that was weird, but maybe more fun than you expected it to be. The strength, perseverance, and fortitude of all of our graduates is what makes me believe that we will get through these challenging times and emerge into a new and improved normal. You should all be very proud of your remarkable achievements under extraordinary circumstances. Thank you for showing us the way. So with that, I would like to toast all of the 2020 class of PhD graduates from the Nicholas School of the Environment. Cheers and congratulations.
Congrats.
Cheers and congratulations, everybody.
Cheers.
Well done, all of you.
Well done.
Really wonderful, exciting to hear all that work.
Thank you.
Yeah, super proud. Thank you.
Bravo, all you.
Congratulations.
Congratulations all.
That concludes today's session, but if anyone else wants to have final remarks, please do so.
Javier, it looks like you've got like a partially functioning invisibility cloak from Hogwarts. Your drink is fading in and out of focus.
Next time I'll improve it. Cheers, everyone. Until next time.
Salud, Javier.
Cheers.
Salud.